entering the paradigm shift. In the last video, we extended the microchip life cycle trend forward into the 2030s, and the result already looks extreme. Product life cycles shrink below a single year, while thousands of highly specialized chip designs appear in parallel, serving more niche markets. And importantly, there's no sign this pressure stops there. Over the following decades, the forces driving this compression only intensify. But once you reach a point like this, extending the chart further stops being useful because you're no longer projecting a trend. You're approaching a paradigm shift, a place of real uncertainty. In this video, we're going to explore how technology could actually push us through that transition, why societies are being driven in this direction, and introduce the idea of a friction matrix, a way to evaluate why some societies are positioned to move faster than others, even while prioritizing stability. Human-centered systems. If the next steps of this technology trend feel impossible, there's a reason. Our intuition is built around human-centered systems. Today, major technological projects start with hiring, assembling teams of people to do all the work required just to get a project off the ground. That includes aligning incentives, coordinating schedules, securing funding, and choosing locations. Planning alone can take months or even years before anything is built. Even once a project begins, testing and iteration are slow and expensive. Prototypes are limited, feedback cycles are long, and mistakes carry real costs. So when we look at projections like this, we naturally imagine today's system being pushed harder, not replaced. And under those assumptions, the projection really does look unrealistic. AI-centered systems. So for this projection to be real, something fundamental has to change. Instead of humans assembling teams, planning projects, and coordinating work, the development loop itself has to become automated. In an AI-driven system, AI engineering teams can be created on demand, spun up instantly for a specific problem. Designs are generated in massive parallel, prototypes are inexpensive, and thousands of variants can be produced and tested at once, not as test versions, but as real products. Data flows continuously across the system, turning design, production, deployment, and feedback into a tightly coordinated network that optimizes in real time. And this doesn't apply only to microchips. The same logic extends across the economy, from electronics to manufacturing and medicine, where even highly customized products can become cheaper than today's mass-produced ones. Unlimited human demand. The demand for this kind of system isn't new, it already exists. People want products and services that are more personalized, more efficient, and better matched to their specific needs. They always have. What's been missing is the ability to deliver that at scale. The same pressure appears in much higher stakes areas. Military systems must adapt faster than adversaries or fall behind. Many countries face aging populations that, on current trajectories, threaten economic and social stability. And every major advance feeds back into new constraints. More capability drives higher demand for energy, food, transportation, materials, and coordination, creating new bottlenecks that must be solved just to maintain stability. As technology advances, these pressures don't ease. They compound, pushing societies toward systems that can adapt faster across the entire economy. Unlimited human fears. So at this point, we're finally at the crossroads, where two forces we've been tracking throughout this series collide. On one side, there is continuous, long-term pressure pushing societies toward faster, more adaptive, more specialized systems. That pressure doesn't turn off. On the other side, every society has mechanisms designed to preserve short-term stability. Legal systems, safety standards, labor structures, and institutions all exist to prevent rapid disruption. When these pressures push beyond what the current system can absorb, something has to give. The status quo stops working, and that is what a paradigm shift actually looks like. The question then becomes whether we can systematically evaluate how prepared different countries are to make this transition, from a human-centric paradigm to an AI-centric one. The friction matrix. Different societies face the same long-term pressure for growth and the same need for stability. Yet each country enters this paradigm shift, this technological revolution, from a very different starting position. To evaluate those different starting positions, we need a structured framework. In this series, that framework is the friction matrix. At a high level, the matrix focuses on 5 factors that are strongly correlated with how far AI and automation can reach into the economy and actually drive change. These are the factors that become decisive at a technological phase change: privacy, safety, digitization, ownership, and government. In the next episode, we'll take these one by one to show why these 5 factors are so critical to whether AI and automation can actually operate, scale, and drive change in the real world.